Hi, everyone. Welcome once again to our channel, Making Life Easier. We are glad to welcome you once again to our series on engineering mechanics. Kindly subscribe, like, share, and leave your comments and suggestions at the comment section. Today we are looking at analysis of trusses using method of joints. And we are going to use distances. We are going to calculate our forces using distances. In our previous video, we look at analysis of trusses using the method of joints, and we solve using angles. Today, we are going to solve using distances with the same example, and then we will see how to solve using distances. Let's quickly go to our question and see how we can be able to solve. Find the force in each member of the structure below. We want to solve this question using the distances around it, not the angle as we solved previously. Good. Let's look at how to solve our question. Anytime you are giving questions on trusses to analyze, the first thing you need to do is to draw your free body diagram. Therefore, let's see how we are going to draw our free body diagram with this. We can draw a straight line. We are going to represent the members with just simple lines. We have this, and we have that. We have that like this. And then we have this here. And the support here, this one is A. Then let me finish the division. This is A, this is E, and this is D. And this side is C, and we have B at this side. And we are told that there is a support at A, and the support there is a pin support. When it's a pin support, we have two reactions, one in the X, let's call it AX, and another one in the Y. Let's call it AY. And the one at P, anytime you see like a circular object down there, like this, or small circles down there, it means that it is a rocker or it's a ruler. So in this case, it is a rocker. And a rocker have only one reaction. In this case, you can see that this rocker will enable us to move horizontally, but will not allow us to move vertical. Therefore, our reaction will be in the vertical axis, and we can call it EY. And we have a force at D already. We are told that it's 4 kilonewtons. We also have another force at C. We are told that it is 5 kilonewtons. And we have another force horizontally at D. And we are told that it is 3 kilonewtons. Good. And we are told that the distance from this to that is 12. This is 12. This is 12. And the height, we are told that the height is 5.2. 5.2. Now, what we need to do is to simplify our problem. The first thing you need to do after drawing the free body diagram is to use the equations of equilibrium to determine the reactions as support or the external forces. And once you are done determining the external forces, now you can determine the internal forces by disassembling the member or splitting the member and analyzing each joint. Therefore, let's first determine the reactions as support. We know that it is two-dimensional. Therefore, our equilibrium equation will be sum of moment will be equal to 0. Sum of forces in the x is equal to 0, and sum of forces in the y is equal to 0. But before we use these equations, first of all, we need to simplify our problem. We know that the height here we are given as 5.2, and this is symmetrical. From this to that is symmetrical. Sorry, we are told that the distances are 6, 6, not 12. This is 6. This is 6. This is also 6. This is also 6. And if from this point to that point is 6, then because it is symmetrical, this side will be 3. This side will also be 3. We can also divide here. We know that the length here is 5.2. This side will be 3. This side will be 3. We can also divide this side. We have 3, 3, and then we have 5.2. Now, because we want to determine our truss system using distances, there is a need for us to calculate our hypotenuses. So in this case, for this triangle, this will be a hypotenuse. And we know that the hypotenuse is always equal to square root of the other 2 squares. Therefore, we have 3 square plus 5.2 square. And from there, our hypotenuse will be equal to 6. It will be equal to 6. This side is 6. This side is 6. This side is 6. This side is 6. Good. And once we have been able to do this, we can determine our external forces. This is equal to 6. We can be able to determine our external forces by saying that always, if you want to take the moment at the point which has most of the forces. In this diagram, we can see that at point A is where we have most of the unknowns. At A, we have AY, which we don't know. We also have AX, which we don't know. Therefore, it will be appropriate for us to take our moment at A, and then we assume that the anti-clockwise direction is positive. Taking moment at A, it means that now we pick all the points and we multiply by the distance. Therefore, we can pick our 3 newtons here. You can see that it is a horizontal force. Therefore, the distance to where we are taking the moment will be a vertical distance. And this will give us, we know that the length of this is 5.2. Therefore, we are going to get 3. No, the formula for moment is always distance times force. Let's stick to that. Therefore, the distance there will be 5.2 times our force, which is 3. But you realize that where the force is applied, if the force is applied here, it will cause, this is where the force is applied, and this is where we are taking our moment, it is fixed. So you find out that this is going to rotate the object this way, and this is clockwise direction. Therefore, this is going to give us negative. And then we come to our next force. This one is 5 kilonewtons. It's also a vertical force. Therefore, the perpendicular distance, 5 kilonewtons, is a vertical force. Therefore, the perpendicular distance is going to be a horizontal force. This is the line of action of that force. So the force can be placed on all these lines. Therefore, you can see that the perpendicular distance will be from this point to that point. And we know that from this to that is 3 plus 3 plus 3, which is 9. We are going to get 9 times 5. And we check whether it will be clockwise or anti-clockwise. Now you can see that if the force is applied here and the distance is like this is fixed. What is going to happen is that the force is going to rotate this body in this direction, and this is clockwise. So that will also be negative. So we pick our 4, it's also coming down. We are going to get, it's a vertical force. Therefore, the perpendicular distance will be from this point to that point. And that will be 12, which is 3 plus 3 plus 3 plus 3. So we have 12 times 4. Would that be clockwise or anti-clockwise? It is coming down. From the principle of transmissibility, this can be indicated as this. And this is where we are taking a moment. Therefore, it's going to rotate the object in this direction, which is going to also be clockwise, and clockwise is negative. Plus, our EY is going up. That one will rotate in the anti-clockwise direction. Therefore, we are going to get 6 times EY is equal to 0. And from there, when you calculate, you simplify the equation and you calculate EY. EY will be equal to 18.1 kilonewtons. Then we can also apply our sum of forces in the Y is equal to 0. Sum of forces in the Y is equal to 0. Now let's look at our forces in the Y. We have AY moving up. If it's moving up, don't forget that our conversion is like this. Anytime you are moving this direction on X, it's positive. This direction on S is negative. This direction on Y, positive. This direction on Y, negative. Therefore, you can see that our Y is moving up. Therefore, we have positive AY, positive AY. This force is coming down. Therefore, it will be minus 5. This force is down, minus 5. This force EY, we had it to be 18.1. This is 4. Then we have plus 18.1 is equal to 0. And from there, you realize that our AY will be equal to negative 9.1 kilonewtons, which means that the direction we indicated here is not right. It should rather point downwards. The direction for AY should rather point downwards. Good. Then we can also use our equilibrium equation. F of x is equal to 0. F of x is equal to 0. And f of x, we know that we only have 2x. This is going that direction. This is going that direction. And we said that this direction will be positive. It's in the positive direction, but this one is in the negative direction. Therefore, we are going to get 3 minus ax is equal to 0. And from there, we can see that ax will be equal to 3 kilonewtons. 3 kilonewtons. Good. Once you have been able to determine the external forces, now what you are left to do is to dismember. What you are going to do is to dismember the entire truss system. How do we dismember the entire truss system? We dismember and analyze the individual joints which make up the truss system. Therefore, from here, you are going to indicate your direction first using the third law of motion. If using the third law of motion, we are going to get our directions using the third law of motion. Using the third law of motion. From here, if this member is exerting a force on this boat will exert an equal force. So let's take it that the force this boat is exerting, this joint is exerting on this member is going this direction. Then the one which this boat is exerting on the same member will be in the opposite direction. If this moves in this direction, then the one exerted by this boat on this joint on the member will move in the opposite direction. If the one of this is going that direction, then the one of that will be in the opposite direction. This will be that, and the other will be in the opposite direction. If this goes in this direction, then the one this boat is exerted on the member will be opposite. We indicate that for all the sides, and we stick to that throughout our. We are going to stick to that throughout our analysis. Having been able to indicate the directions, now let's take the joints one after the other and analyze. However, anytime you are doing the analysis, because we are going to use our two equilibrium equations, sum of forces in the x is equal to 0 and sum of forces in the y is equal to 0, always make sure that you pick the joints which have a maximum of 2 unknowns. You pick the joint with a maximum of 2 unknowns. Therefore, you can see that for A, only 2 members are meeting at A. And therefore, we only have 2 unknowns. We can analyze joint A. When we pick joint A, we know that we have 2 external forces. We have AX and AY. We have AS going this direction. We have AY, which we calculated to be negative. Therefore, it will be moving downwards. And we know the value is 9.1. And AX is 3. We have the force from A, the member from A to B. Therefore, let's represent it as force AB. And this is the direction. And then we have one horizontal force like this. And the horizontal force is moving from A to E. Therefore, we can call it force AE. And call it force AP. Then now, anytime you get the forces like this is in the X, this is in the X, this is in the Y. But this force AB is not in the X or in the Y. And therefore, you need to resolve that force into X and Y. How do we do that? We just complete it to form a rectangle or whatever. You can see that if you want to move from this point, look at the direction. We are moving from point A to point B. It means that we are going to move up like this and this direction. But don't forget that our horizontal distance, when you are moving from A to B, when you are moving from A to B, horizontal distance is 3. This is 3. And the vertical distance is 5.2. The vertical distance is 5.2. And the hypotenuse is 6. Hypotenuse is 6. And we said that we are going to move up on Y. When we are moving up, is positive. And the distance on Y is 5.2. Therefore, resolving that force will be FAB times the vertical distance, which is 5.2, over the hypotenuse, which is 6. And from there, X, we also move this direction to the right. And we said that to the right is always positive. And it will be, because the horizontal distance from A to B is 3, that force will be FAB times 3 over the hypotenuse, which in our case is 6. Then from there, we are able to resolve. So we can apply equilibrium equations of f of y is equal to 0. Now, f of y is equal to 0. We are going to get our equation like this. This one is in the y. Look at it, it's coming down. So negative 9.1 plus our y component for FAB. Our y component for FAB. Our y component for FAB, which we have seen that the y component for FAB is going to be FAB times 5.2 over 6 is equal to 0. And from there, we can make FAB the subject. FAB will be equal to 9.1 over 0.866. And this will be equal to 10.5. This will be equal to 10.5 kilonewtons. Once you are done with FAB, we can now apply our second equilibrium equations. Sum of f of s is equal to 0. Now we have 3 s components, this, and the s component there. But look at this one, it is going in this direction. It is moving to the left. This is moving to the left. It's moving to the left. And because it is moving to the left, we said that it's going to be negative. We have -3 plus this one is moving to the right, and so it's positive, plus FAE plus the S component for the one we resolved, which now is 3 over 6 times FAB. But we have already calculated for FAB. We have already calculated for FAB, and we can substitute. So from there, we are going to get FAE will be equal to -0.5 times 10.5 plus 3. And from there, our FAE will be equal to negative 2.25 kilonewtons. Good. Now our FAB, let's write them here. FAB is equal to 10.5. Our FAE is equal to negative 2.25. Good. From here, allow me to clean all this so that we can get a lot of space for analysis of the other remaining joints. Kindly allow me in that. Good. Now we have been able to analyze joint. We have been able to analyze joint A. And so we have been able to determine the forces in member AB and in member AG. And therefore, let's look at the next joint, which we can analyze. We had already stated that always analyze the joint with two unknowns first. Therefore, from what we have done, you find out that now when if you want to analyze E, joint E, we know A to E, FAE, but we don't know from B to E, we don't know from C to E, we also don't know from C to D. Therefore, we have three unknowns. We cannot analyze joint E. However, when we go to B, we know from A to B, we'll be left with B to E and B to C. We can therefore analyze that. We can say that we can analyze joint B. This is joint B. We want to analyze the forces on B. Analyzing the forces on joint B, we have one force coming down like this. This is the direction. And then we have, this is from A to B, it's the same as from B to A. We just maintain the name, force AB. And we also have another one which is moving from B to E. We can call it force BE. And this is the direction. And then we have a horizontal component here which is moving from B to C. We can call it force BC. Therefore, we need to, these ones are not in the X and it's not in the Y. We need to resolve. But we already know that the horizontal distance from B to A, horizontal distance from B to A, as we have done here from B to A is, horizontal distance is 3 and the vertical is 5.2, the hypotenuse is 6. Therefore, we have 3, we have 5.2, and then we have the vertical to be, the hypotenuse to be 6. Therefore, if you want to resolve this force, look at it, we are going to move this direction on X. And this direction on X is negative. Our force is therefore going to be negative FAB times horizontal distance, which is 3, over the hypotenuse, which is 6. We can also do that for the vertical. The vertical distance is 5.2, which will give us FAB times the vertical distance, 5.2, over the hypotenuse, which is 6. And we do the same for this force here. The force from B to E. From B to E, the horizontal distance is also 3. The vertical is 5.2. And then the hypotenuse is 6. Therefore, we have 3, 5.2, and then we have 6. And looking at the direction of the force, we are going to, don't forget that here on the Y also, we're moving downwards. On the Y, we're moving downwards. And if you are moving down, it's going to be negative. Now let's resolve for this side. You can see that if you are moving from this point B to point E, from point B to point E, we are going to move down on Y. And if you are moving down on Y, it will be negative. We have negative FBE times the vertical distance is 5.2 over the hypotenuse, which is 6. We can also resolve the one for Y. The one for, that is the one for Y. The one for X is going to move to the right. It's going to move to the right, and to the right is positive. Therefore, the horizontal component is going to be FBE times 3 over 6. From here, we can just sum our X and Y components. Sum of f of X is equal to 0. and sum of f of y is equal to 0. Let's first use our f of y. Sum of f of y is equal to 0. Therefore, f of y, we have the y component for this FBE and the y component for FAB. We can write it as, for FAB, we have negative FAB times 5.2 over 6. And we write for FBE is also negative FBE times 5.2 over 6 is equal to 0. From there, we know FAB, we have already calculated at 10.5. Wherever we see FAB, we can put 10.5. But we are going to get 0.866 times 0.5 times 10.5, 10.5 minus 0.866 FBE is equal to 0. And from there, our FBE, if you do the analysis, your FBE is going to be negative 10.5 kilonewtons. Once you have been able to do that, we can also write our x equations, which will be equal to 0. Our x, we have 4. We have 3 of them. We have this FBC is going to the right, so it's positive. We have FBC plus the S component for FBE is positive. That is what we have here. That is what we have here, which is FBE times 3 over 6. And then we also have the S component for FAB, which is negative FAB times 3 over 6 will be equal to 0. Up to this point, we know the value of FBE and we also know the value of FAB. We just substitute them into the formula, and then we are going to get, from there, we are going to get FBC will be equal to negative 0.5 times negative 10.5 plus 0.5 times positive 10.5 minus 3 do we have FBC? Good. Good. Yes, sorry, at B there was another force there, which is 3. There was another force going this direction. Look at it. There is another force which was moving in the right direction here. There was another force which was moving in the right direction. And look at the force. It was 3 moving in that direction. Sorry for that. So it can be indicated here. 3. Therefore, we can add our 3 here plus. It's moving to the right. So plus 3 will be equal to 0. And this one will be minus 3 will be equal to 0. And from there, our FBC will be equal to 7.5 kilonewtons. We have also been able to calculate FBE. We have FBE, which is equal to negative 10.5. And then we also have our FBC now. FBC, which is equal to 7.5, which is equal to 7.5. Good. Now we can move on to another joint. We can move on to another joint. We can move on to another joint and analyze. From here, we can now move to joint A, because we know A to E, and then we also know the force in member BE. Therefore, we only have 2 unknowns now at joint E. We can quickly analyze joint E. If this is joint E, this is joint E. We have one member going this way. That one is from E to D. Therefore, we can call it FED. We also have one member from A to E, we can call it force AE. And this is the direction. This is the direction. We have one member moving up like this. That is from E to C. Therefore, we can call it force EC. And then we also have one force moving that direction. And we can refer to it as force BE. Let's still maintain our BE. Then we resolve. Don't forget that we also had one vertical force down here. We have one vertical force, which we found to be 18.1. And we said that it was moving 18.1 was moving up. It was moving up. Sorry for that. Let me clean and do it well so that we can all be able to follow. We have one force pointing upwards like this. This is 18.1. And we need to resolve all the ones which are not in the X or in the Y. Therefore, we are going to resolve FBE. We are going to resolve FBE. Resolving FBE, you can see that we move this distance on the Y. We are moving up, so it will be positive. And this distance on the X will be negative, but this will be positive. And we know that the vertical distance, FBE, the vertical distance is 5.2. The vertical distance, sorry for that. The vertical distance is 5.2. This is 5.2. The horizontal distance is 3. And the hypotenuse is 6. The hypotenuse is 6. Therefore, our Y component is going to be FBE times the vertical distance, which is 5.2 over 6. And our horizontal component is going to, we have already stated that it will be negative. Therefore, we have FBE times 3 over 6. Then we resolve this force also into X and Y. This force here, we can resolve it. Now, if we want to resolve, you can see that in that case, we also move up on the Y, which is going to be positive, and then we move this direction on the X. So X is also going to be positive. Therefore, we have positive for both X and Y. On the Y, don't forget that the force is FEC. So we have FEC, we said that it will be positive, and the vertical distance is 5.2 over 6. And the horizontal will also be positive, FEC times. Now the horizontal distance is 3 over 6. Then from here, we can write our equations. We can say that sum of f of y is equal to 0. And f of y, we are going to get 18 pointing up, it will be positive, plus the y component for FBE, which we are getting to be FBE times 5.2 over 6. And the y component for FEC, which is also 5.2 over 6 times FEC is equal to 0. But don't forget that you have already calculated FBE, and therefore we can substitute the value of FBE, which is FBE is negative 10.5. FBE is here, negative 10.5. Sorry for that, FBE is here. FBE. Therefore, we are going to get FEC will be equal to negative 18.1 minus 0.866 times minus 10.5 all over 0.866. And from there, FEC will be equal to minus 10.4. Minus 10.4 kilonewtons. FEC is equal to minus 10.4. Then we can write for S, sum of X is equal to 0. X, we have FAE, which is going that direction, so it will be negative FAE plus FED is going that direction, so it will be positive FED. And the S component for this, which is negative, we have minus FBE. We know FBE. We have already calculated FBE to be 10.5. FBE times 3 over 6. And then we also have for FEC, which is plus FEC times 3 over 6 is equal to 0. Then from there, we substitute FBE and FAE and also FEC. We can substitute those ones. And then our equation will be equal to FED will be equal to we already know FAE. FAE what you have here is FEC. FEC. FAE is negative 2.2. So we have it's equal to positive. FE is going this direction, we said that it will be negative. And we have negative, positive here. FEO is already negative, and this is negative also. Therefore, we are going to get negative 2.25. And then we have calculated FBE. FBE is 10.4, 10.5. That will give us, but when it crosses the equal sign, the sign will change. So you are going to get 10.5 times 0.5. And then the last one, which is FEC, which you have calculated, 0.5 times 10.4. When it also crosses the equal sign, it was negative, and FEC from here was positive. Good. So when it crosses the equal sign, it is going to give us negative 10.4. Negative 10.4. And from there, our FED will be equal to negative 2.25. Negative 2.25. Negative 2.25. Good. Good. Sorry, FEC was supposed to be 10.4. Okay, 10.4. That is right. Good. So you are going to get negative 2.25 or something like 2.26, something very small. Something very small. So this will be left with 0.1. So this one will be like 0.6, negative 2.26. Then from there we have also gotten FED. FED equals negative 2.25 or negative 2.26. Let's take it to 2.26. No, this is giving us 2.25. This is giving us 2.25. So this is 2.25. That will be 2.25. Good. So from there, we can now analyze the last joint, because we can choose to analyze joint D, or we can also choose to analyze joint C. By the time we finish with joint D, all the members, because even now we know this member, we are only left with this member. Therefore, we can decide to just analyze either C or D, and we can use the other one to check for the accuracy of our answer. Quickly, let's analyze joint D, and then we bring our question to an end. We bring our question to an end, and we check how to go about it. We want to lastly analyze joint D, and then we see what we are getting from there. Therefore, let's draw the free body diagram for joint D and do our analysis. Good. Now from there, joint D, we have been able to analyze all the joints. Joint D, we have one force coming this way, and it is called FED. And we have also another force coming down, which is 4 kilonewtons. And then we have another force in BC going this way. Therefore, we can call it force BC. Then we resolve this into components. You know that the horizontal is 3, vertical is 5.2, and the hypotenuse is 6. Therefore, if you want to move from this point to that point, you are going to move up on Y. Y will be positive, which will be FBC times 5.2 over 6. Then we can move this direction on our X, which will be negative FBC times 3 over 6. And from there, we can resolve, we can use the horizontal component. We can say that FED, look at the direction, it's going in the negative direction. So negative FED minus F 3 over 6 times FBC will be equal to 0. We know FED already, which is, we already know FED, which is negative 2.25. Therefore, our result will be equal to FED will be equal to minus 0.5 times negative 2.25. And from there, our FDC will be equal to 4.5 kilonewtons. Now we can use this side because you have already calculated FDC. We can check whether when we sum the Y to be equal to 0. So this is for sum of f of x is equal to 0. We can check the accuracy of our results by using sum of f of y should be equal to 0. And here we only have two y's. We have 4, which is coming down, minus 4, and then the y which is going up. We have FBC times 5.2 over 6 is equal to 0. And you find out that when you put FBC, which is 4.5 here, you are going to get negative 4 plus 4.5 times 0.866 is equal to 0. And you realize that we are getting an answer to minus 4 plus 3.89 something. This 89 is because of the approximations, the error in approximating, but it's almost the same. Therefore, our solution is right. Our solution is right. This brings us to the end of our question. However, it is pretty simple. Just that there are a lot of analysis for you to do. With this, we can say that we have confidently solved the problem. We solved using the angles, and we have also solved using distances, and you realize that the two of them are giving us the same result. They are giving us the same result. However, if you have any comment or suggestion or any question, you can let us know at the comment section. We are very grateful for your time. Once again, what we want to say is that thank you so much for watching. Kindly subscribe to our channel, like, share, and hit the notification bell as well. See you in our next video when we'll be doing analysis using method of sectioning. Bye-bye.